Hey guys, welcome back to the channel. So let me see if the stream is started. Like, is it not lagging? Okay, I'll just quickly go through the video. Okay, so it looks good. So we can start. So yeah guys, how was the contest today? So we have one concurrent viewer. I hope it's not me. So the plan today is to solve some random problems, like some random problems from past contest based on a particular rating in order to cover a variety of problems and also include problems which lie in specific rating range so that we can increase our rating. So yeah, so I'll just quickly type it over here for the guys who will join later. Rating range. Okay, so let's start. So let's start from, let's say, rating 1600 to 1800. 1600 to 1800. Okay, so we got a few question 3s also in covered in this question 2s, which is fine. So I'll just randomly select a question. We have solved this in the previous contests, so I don't think I should waste time in these problems with minimum difference. We have solved this. I think we have discussed in the previous stream, so I'm not going over it again. Also this is also solved, I think. Yeah, we have solved in the recent contest. Let's quickly select a random question. Okay, longest common prefix between adjacent strings. Okay, seems to be an interesting problem. Let's see if we can solve this problem. Okay, so we have 0 viewers. Okay, so let's start with this problem. So the problem is longest common prefix between adjacent strings after removals. Okay, so you are given an array of strings words for each index I in the range 0 to words dot length -1. Okay, perform the following steps. Remove the element at index I from the words array. Okay, compute the length of the longest common prefix. Okay, among all adjacent pairs in the modified array. Among all adjacent pairs, so do we need to pair it with all the elements? Return an array answer I. Pair answer of I is the length of the longest common prefix between the adjacent pairs after removing the element at index I. Between the adjacent pairs. Okay, so if we remove this element, then for the remaining elements, do we have to find the longest common prefix? Is this the thing? If no adjacent pair remain, or if none share a common prefix, then answer of I should be 0. Okay, so removing index 0, so we have, okay, these elements, and the longest common prefix is run, which is having 3 characters. Okay, got it. So we have to remove the element or string from this array one by one, and once we remove that string, we have to find the longest common prefix of the other elements. Okay, longest common prefix of the other elements. This can be solved using a try. Is there any other way that we can explore? Okay, I have not revised try from a long time, but okay, we have one note. Let's see how we can do this. Okay, so let's say we have these letters, so we can pair them as, let's say for the first string we have J, then we have U, then we have M, and maybe we have P. Here we would be having all other characters as well, but I'm not adding them for now. Okay, for run we have maybe R here, then we have U, maybe U here. Although in try we do have all the characters at each node, but I'm excluding these nodes and I'm just trying it. And okay, another run which is R, same. So instead I would say R is 2 times, U is 2 times, N is 2 times, all the other guys are 1 times. Okay, and this is the starting point. Okay, then we have jump again, so we have this as 2 2 2 2, and then we have run again, so run becomes 3 3 3 3. Okay, so jump is 2 times and run is 3 times. So this is try is basically a structure, like we connect all the characters by node, and let's say we first add one string here, so it is run, so R will be here, U will be here, N will be here. Okay, then now let's say again we have run, like the second string is also run, so we again add this, so we already have run here, so we will increase its count. Now the count is 2. Again for U the count is 2, for N the count is 2. So in this manner we maintain a string in the tree like structure so that we can perform operations efficiently on this. Okay, so now considering this example, our array is jump, run, then we have again run, then jump, then at the last it is run. Okay, so if we remove this, so what if we remove this? So here it was 2, so it will become 1. Again here it was 3 plus 2, here it was 5. I'll write clearly here as 5. So 5 will be reduced by 1 because we removed 1, remove jump. Okay, so we have 4, again 2 will become 1, and here it is 1. So now what we have to find is, we have to find the longest prefix, like the length of the longest prefix. So if we start iterating from these first characters, if we iterate from this and this, we see that it is 1 times, it is again 4 times, but since we are considering this previous character as 1 time, hence we know that this is also 1 time, because if we are considering this as a complete word, then after that only one character, only U will occur only once, because if there are two U's, then we may add it like this. So currently we have 1 U. Okay, then this, and then here it is 1 1 1 and 1. Okay, so the longest common prefix is of length 4. Okay, if we consider this. Okay, but we have a one word. Okay, we have a one word, so it starts with 1. So we have one word having this longest common prefix starting with J. Okay, then here we have 3 words having longest common prefix starting with R, so we will consider this R, because 3 words are starting from this R, so here the answer is 3. Similarly, then we can again add this jump so that the count will be 2 again, and then again for this run we will reduce this guys by 1, so it will become 2, then from 5 here it will become 4, and again here it is 2. So jump is 2 times. From here we have 2 times jump, because here the prefix is, like the count of J is 2, again R is also 2. So can we select both of them? Can we select both of them? we remove run, we have 2 run and 2 jumps. Can we select both of them? No adjacent pairs share a common prefix. Can't we take run and run or jump and jump? Why can't we take this, guys? So here we have run, 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 and here it is asked a return an array answer where answer I is the length of the longest common prefix between the adjacent pairs after removing the element at index I. So do we need to consider all the pairs? Here words became this. Longest common pair is run. Longest adjacent pair is run and run. Okay. Having the common prefix run. Okay. Removing index I, words became this, 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 and this. No adjacent pairs share a common prefix. Okay, so why is it not considered? Are we missing something? Hey guys, are we missing something? Mark your attendance, guys. Okay. So among all adjacent pairs in the modified array, okay, all adjacent pairs, okay, if we remove this, this is one adjacent pair, this is one adjacent pair, and this is one adjacent pair. So it basically simplifies our question, I think. Okay, so here we have run, and hence it is of length 3, and when we remove this run, we have jump, run, jump, run, and no two adjacent pairs have the common prefix. So I don't think we should even use try. It is even simpler. What can we do? Let's see. Okay, I missed that adjacent part. So yeah. So the previous example was a bit harder, like a harder question considered to this, because it uses tries, because there we assume that we don't have any adjacent pairs, although we took all the pairs and we can pair any two elements, and then we while iterating through this array, we can remove any element, and then from the remaining elements we have to find the longest common prefix. That's a standard question used in tries. Okay, so that was a learning for all of us. So now we have jump, or maybe I can just increase its width. We have jump, then we have run, then we have run, again we have jump, and then we have run. Okay, so what I'm concerned about, for every element I'm concerned about its next element and the previous element. Okay, considering that these two guys are there. Okay, now let's say I remove this. So what happens? So this guy depends on this instead of depending on this. Okay, that's an observation here, but we know that we are removing this. So can't we point the right of this to this guy? Can't we do that? And similarly for this guy, we can just point it over to this part, because we know that we are removing this. Okay, yeah, I think it's a basically easy problem. We can just iterate over this elements in the array. And then what we can do is, when we came across an element, we will check. Okay, let's say it's a first element, then we will basically check from all these guys who is having the longest prefix. So how can I do this operation faster? How can I do this operation faster? Is there anyone who can suggest? Or do we have some viewers? Okay, we don't have some viewers yet. Okay, we have some viewers. Hey guys, so can we solve this together? Can we do so? Can we do so, guys? Okay. Iterating over this array, what we have to do is we have to calculate the longest common prefix among all the elements if we remove a particular element. If we remove a particular element, then okay, from this complete array we have to take the max. How we get this? Again, a harder topic, but segment array is one possible answer for this, because we can pre-compute all these prefixes of adjacent pairs, and then when we remove a particular element, then what we can do is we can take the maximum among this complete array in O of n log n. Okay, so this is for building the segment tree, and we can just query in log n. We can do this to get the maximum element. So we can do this for every index, and then we will get our answer for each index. So that's a possible solution. But let's look at some easy solution. So let's say I have all these things written over here. This is our question. Okay, we have this. Then let's say I compute all the prefixes, like all the maximum prefixes for all these elements. Okay, so for this we have this as the right guy. So if I maintain the prefix in the form of L and R, then it would be on L it is 0, on R it is 0. Okay, if we consider this run, on the left side it is 0, and on the right side it is 3, or this guy matches with this, so I think we can write 3. On the left it is 3, on the right it is 0. Yeah, on this we have 0 because this guys will be same, this will be same, and this will be same. Okay, so here we have again 0 because it is surrounded by run on both the sides. Again it is 0. Okay, so if we are considering for this element, what we can do is we can take the answer for this complete part, like the maximum of this part. Here it is 3, but how can we calculate this maximum efficiently? Can we use prefix sum? Let's see if we can use prefix sum here. Okay, let's say I calculated the suffix and prefix. Then for each index, can I get the maximum element? Yes, I think we can get. So here we have the maximum as 0, 0. Here it is 3, 3. Here again it is 0. Now going from this side, we have 0, 3. Again we have 3, 0, 0. Okay, on the left side it is 3, on the right side it is 3. Okay, this is, I would say, suffix, and this is prefix. Now let's say I am at this index and I remove this. So what I'll take is, I'll take the maximum of this, this and this guy, but here it is the first element, so we don't have any element to before this, so the maximum is 3. Okay, now whenever we are at this position, we can take the maximum of this. Okay, but the maximum here is 3, which is for this. Okay, so what we can do is, we know that we have LNR. Now we are removing this guy. Okay, which means that this will be reduced, and we know that this and this will be same. Okay, so we can remove this from this, and what we can do is, we can consider the suffix part of this next element, which is 0, and from this previous element we can take the prefix part, which is 0, so the maximum would be 0. So what if we go in this way? Then we will get how much elements can be formed if we remove this, like what is the maximum length string, such that for this we consider the right part and for this we consider the left part, but we miss a case where these two can also be paired. Okay, for this we can just simply calculate the prefix there itself. That's not a problem, I think. Yeah, we can do that. So here basically we have 3 operations, this, and like the prefix, the suffix, and the calculation based on these two guys, like these two border elements. So it is 0. Again, for this we go to the right part, we check the second value, it is 0. Okay, we go to the left part, we check the second value, it is 0. Okay, then these two guys, again these two does not share a common prefix, so it is 0. When we go to this, we take the maximum of this or this, okay, which is 3, or maybe this, which is again 3. So 3 and 3, the max is basically 3. So when we go to this this basically index, then we can say that there is no next element because this is the last element, so we can take the maximum of this, or there is no right element, so we cannot share it with the right part, so basically the maximum with 0, which is 0. So we have this answer, and why it is wrong? Okay, we got rid of this run. Okay, so we want the maximum among this. So when we go to this part, we were having the maximum as 3 because we are checking from the suffix part, or having we are checking from the prefix part, so it is 3. Okay, so here it will be 3. Okay, so the idea is clear. I think we can code this solution. The idea is clear, we can code this solution. Okay, let me just increase the voice. Hello, am I audible now? Clearly? So is the audio louder now? Okay, bro. So do you got the solution? Should we code this? Will it work? So what we basically do is, for every element, let's say we have some elements in this manner. Let's say we have some elements, or maybe these are colored elements. Let's say I color this. We can assume this problem in this way. Let's say we have colored these guys. Okay, now here again it is, let's say red color, and maybe here it is green. So what we are essentially doing is, for every element, if we remove this element, then we have to say that how much is the maximum prefix which can from on the left and right side. So what we do is we maintain a prefix and suffix to calculate the maximum from this side and this side. Okay, now after we remove an element, we check what is the maximum on the right side, such that we here also there are two parts, that is it can be combined with this and it can be combined with this. So for this element we check the left part, and on this side we check the right part, so that this will be skipped. Okay, right part, and we take the maximum from this suffix and prefix guys. We take the maximum from this suffix and prefix guys. Okay, and once we have this, we also try pairing this, because once we remove this, this can also form a pair. So based on three values we got our answer, and this is the idea that we are essentially trying out. So what do you think, will it work? Okay, so is it much louder right now? Okay, I'll just reduce it a bit. Let me know, bro. Is it fine now? Okay, the stream is delaying. Let me check it. Let me check, guys. Hi, bro. Hi, Pawn. I think it is much clear right now. Yeah, I agree there is a bit delay, but yes. I'm using a mic, bro. I'm using a mic, and I think it is now clear, because I heard the audio and I think it is cleared. Let's increase it a bit, and I think it is fine now. Yeah. Okay, so we have one approach here. Let's see how we can essentially code this. So for every position, what I want is, I want the maximum in the left part, I want the maximum on the right part. Okay, also there will be two cases for each element, that is it includes the left part and right part. So we have to store this both, guys. Okay, so should we store a pair? Should we pair these elements? For this prefix, should we have a pair? Hey guys, hey. So are we on the same page? So can you guys can you guys just say if you are getting the approach? Okay, so let's say I have some prefix pair and I have some suffix pair. Okay, and I have the element as jump run jump run. Okay, let's increase this. So we, let's say, have some prefix part and we have jump, run, jump and run. So let's calculate the prefix and suffix, and let's see if this solution will work. So what we are doing is, okay, let me just see if you guys are on the same page. Okay, I didn't receive any response yet. I think I can continue. Okay, so we are calculating the prefix and suffix. So for this, the prefix would be, I would say 0, because there is no element on the left, so we have 0. And for this right, we will calculate. So currently we will only consider this element, so it is 0 because these are not matching. Okay, and while going in the right direction or in the left direction, like while traversing the array, we will also take the max, and let's see it will work or not. Okay, now we are at run. Okay, here we check that on the left side it is not like this is not forming a prefix, so we can take the maximum of this current prefix, which is 0, or 0, which is 0. And again for this right side, yes, this is the same word, so the prefix would be the string length, which is 3. Now 3 and max with this guy, which is again 3. Okay, okay, should we max it with this or the result of the previous thing? Let's say we max it with this, so when we reduce, this will also reduce. Yeah, which is in turn the solution which we are proposing, because we are not including this if we get rid of this element. Okay, let's go ahead, then it would be clearer, I think. Okay, so for this, on the left side we have the same element. Okay, so we can put a 3, but let's also see the maximum of this side, that is this left side and art side. Okay, so it is 0, and we have the same word on the left, so 0 and 3, the max is 3. Okay, here on the right side we have this jump. Okay, and these two are completely different words, so we have 0, but we have another element on this right side here as 3, so the maximum of 3 and 0 would be 3. Okay, so for this element we have on the left we have run, so it is 0, and the max of 0 and this 3 is 3. So for this guy on the right side we have again run, which is completely different element, but we have the right of the previous guy as 3, so the maximum is 3. Okay, and for this run we again have this on the right side. On the left side we have completely different words, so it will be 0, and the max with this will be 3. Okay, so for this again we don't have any words, any word on the right, so we take the max with this, which is 3. Okay, so we have this prefix ready. Now let's calculate the suffix. So for this we don't have any word on the right side, so it will be 0, and on the left side we have a different word, so we will start with 0. Okay, then for this jump we have again different word on this right side, so it will be 0, and max with this right part, this is L, this is R, right part, it is again 0. Okay, now for this on the left part we have a different word, so 0, because 0 and max with this 0 is again 0, again this is L and R. Okay, so for this guy on this part we have different word, so it is 0, and max with this is 0. Okay, then again should we consider this with the right part? Yes, so if we consider this with the right part we have 3. Okay, because this is similar, but let's take this maximum with this, which is 3 in turn, because the previous element was 0, so we have L and R. Now again if we go there, like we are at this position, then we see the previous element. Okay, so it is run, so we have 3. Okay, we have 3, and let's max it with this previous one, so it is 3 and 3, the max is 3. Okay, on the right side again we have 0 element. Okay, so did I messed up over here in the left and right? Yeah, on the left part we have 0, because we have jump, and then for this previous elements left we have 3, so here it should be max, it should be 3, because we are taking the maximum of this pairing and the previous left, so it is 3. Okay, and we have the same word on the right side, so it would be 3, and the max with this will be again 3. Okay, so 3 and 0, max is 3. We have L and R. Now for this jump, again on the left side it is different, on the right side it is different word, so it will be 0, but max with this 3, it will be 3. Again on this left side we don't have any word because this is the first word, so again it is 0, but max with this previous L, it is 3. Okay, so let's check if this is the only thing which we have to calculate, and based on this will we get our answer or not. Okay, so the idea was, for each element what we do is we take the maximum from the left, maximum from the right, like maximum among the right for this LNR, maximum with this left, and then we will also pair these two guys. Okay, and then we will take the maximum in these three values. Okay, so we have the idea clear. Let me know if you have any doubts for this. Okay, so pairing with this, let's start with this, and for this guy, first is let's pair with this, which is 0. I'll just draw a line. Okay, so pair with this adjacent element, it is 0. Okay, then we take the maximum of the, this is the suffix, so from this suffix we take the right part, which is 3. Okay, we have 0, 3, and I don't have any prefix because this is the first element, so we only have two guys. That is, this is the adjacent value, and this is the maximum on, I would say, the right side. Okay, later we will take the maximum of this, or I'll just write the maximum here itself. So it is 3. Okay, so for this guy again we will pair it with the adjacent elements. Okay, so like let's say we remove this, so we pair this guys, so we pair this guys. Okay, so as these two are completely different elements, so the adjacent value would be 0. Okay, now what we will take is we will take the maximum of this right, like the right value of this right side, and the left value of this left side. So the maximum here is 0. Okay, 0 on the left and 0 on the right, so 0 on the left, 0 on the right, so I would say max left and max right. Okay, for this again we will pair this, then since these are two different elements, we have the adjacent value of 0, and what we take is we take the left of this previous element and the right of this element, this both are 0, so 0 and 0, here it is 0, here it is 0. Okay, so for this again what we do is we remove this, which means that we can pair this, and if we pair this, these two are same strings, so we have the prefix as 3, and then we take the maximum from this previous left and this next right, so we have 3, 3, 0, and the max here is 3. Now again when we are at this last index, okay, we are at this index, we don't have any pairing on the right and left because it is the last element, so here it is 0, and from the previous left we have 3, and I don't have any element on the right, so it is 0, so here it is 3. So we have 3, 0, 0, 3, 3, and which should be our answer. This has to be our answer. Okay, we have 3, 0, 0, 3, 3. Okay, so this is the correct approach, and we got through the thought process of how we derive to a particular solution. Like we got really slow, and we just got to know the details of how we can use prefix and suffix sum to solve this kind of problems. So let's start coding this. Okay, we have a concurrent viewer. Okay, so who is currently watching the stream, please put some messages, guys. Okay, so let's maintain a pair. In this pair we'll hold two elements, that is the left part and the right part. Okay, we have int of this left, or I would say int left, int r. Okay, and then we have this pair as int l, int r, this dot underscore l. Okay, we have this pair. Then what we maintain is we maintain two arrays. It is the prefix array, okay, so it will be an array of pair. Let's have the n as okay, it is of size n. Then we have the suffix array. Okay, then we have to calculate the prefix and suffix. Okay, let's calculate the prefix and suffix. So let's first calculate the prefix. So for the first element, the left part would be 0 and the right part would be the prefix of this current element with the right part. Okay, so the minimum length of this array should be 2. Okay, so it is 1. Okay, so single element is also possible where we will have answer as 0. So we will say if n equal to 1, then we can simply return new int of size 1, which will have a 0 value. Okay, now when we have these two elements, we can start with this first guy. Okay, and for this first element, prefix of this 0 equal to what? New pair of 0, that is for this left part, and we will calculate for the right part. Okay, so we have to calculate the right part. Okay, should we write a custom function, or maybe we can use some string function? Let's write the custom function only. Get prefix string s and t, and I'll just start with some integer. My dot min of s dot length, because we have to iterate through all the characters at max. Okay, let's see, we have a count here. If here it is 0, if s dot char at, if we have the same character at this position, okay, then what we'll do is we will do count plus plus, else what we will do is return the count. Here also we will return the count. Okay, so we will get the prefix of get prefix of the left and right string. So the left string is words of, okay, this 0, and the right side we have words of this 1. Similarly, we will calculate the suffix for the last element. So it would be basically n minus 1 and n minus 2. Okay, and basically it will be the left part and the right part is 0 here. Okay, we just calculated the suffix and prefixes of the first and last element. For the remaining elements, let's find it. So for this first element, what we can do is prefix of this current element is equal to what? New pair of what? Max of this element paired with this left part or the left part. Okay, max of prefix of I minus 1 dot underscore L, which means that we are getting the prefix of this current element. Okay, we take the maximum of it with the left part, like the left word. So it would be words of I minus 1. Okay, words of I. Okay, and what we have to do is we have to find the prefix of this. So we will say get prefix. So pair of I, so the prefix of I would be a new pair of the maximum of the previous element. Okay, on the left part the previous element and the maximum of this previous word and the current word. Okay, so we got the L, and what will be the right? So right will be basically the pairing with the right element. Okay, the right element. So here what we can say is we can check if we have a right element. So let's say I maintain a int as rt. Okay, let's calculate rt. If I is less than n minus 1, okay, if this is the case, then we can find the answer, else we will say we have 0. Okay, because if this is the last element, then we don't have anything on the right. Else what we have is we will say get prefix of words of I minus 1, I plus 1, and words of this I. Okay, so we took the prefix with this. Instead of prefix, I would say we get the prefix characters, like the prefix string between this current word and the next word. Okay, and we can just place it over here. Okay, so in this way we calculated the prefix. Now we want to calculate the suffix. Let's calculate the suffix. So suffix would be n minus 1 starting from n minus 2 while I is greater than or equal to 0, and we will do I minus minus. Okay, we will do I minus minus, and here we will say suffix. Again, where do we have? Yeah, here we have suffix. Okay, so here we want to calculate to the left part. I would say left, and if this I is greater than 0, then we can calculate the prefix, like we get the prefix of this current element and this element, current element and the previous element. Okay, and if this is not the case, we can just say we have lf as 0. So here it is lf, and I'll just get rid of this rt, because now the suffix would be maximum of suffix of this previous elements, like the previous element right part, or words the dot prefix of this next element and my current element. Okay, so we got the prefix and suffix. Now we can calculate our final answer at each position. Okay, let's say we have this answer. Zero I is less than n I plus plus. Okay, So earlier we calculated three parts. That is, if we are removing a particular word, then we can calculate the prefix of this corner elements, like the two words on this adjacent side of the current word, like the word which is removed. So we will get prefix of, okay, if let's say we have removed the word and we will calculate the adjacent answer. So it would be if I is greater than 0 and I is less than n minus 1, okay, then we will get the answer, else we will say 0, because for the first and last element we cannot form any prefix like the valid prefix, because there is no element on one of the side. Okay, so if there are any elements, then we will say calculate prefix. Let the get prefix of what, the previous word and the next word. Okay, we got the prefix and we calculated based on that our adjacent. Like this is basically the case when we have three words and we are removing this word, so we check if there is a valid prefix with this guys. So we checked that. Now again we have two conditions. Like what we will do is, for this element we will get the maximum of this, basically the max part on the left, and then the third condition is the right part, like LNR, the right part, like the right max part. Okay, so it would be, I think we can name it as RT. And what will be our RT? Okay, if I is less than n minus 1, then we can surely calculate our RT, else we have 0, and the RT would be basically the maximum of, or it would not be any maximum, it will be simply basically suffix of I plus 1 dot underscore R, because we want the right part on the right side, then we want the left part on the left side, and here we will get this if this is greater than 0. So it will be prefix of I minus 1. Okay, and at the end we will just say maximum, like the answer of this I would be mat dot max of this ADJ, or mat dot max of this RT and this LF. This should give us our answer. Hopefully there are no silly mistakes. Okay, so we forgot to return this. Okay, we have a wrong test case. Second one is correct. What's wrong here? Let's try to debug this. Quickly. So is there anyone following up till here? Okay, I'm interested to know who is live right now. Okay, so we have 5 concurrent viewers now. Hey guys, so we are solving some LeetCode problems. Whoever is new on this channel, you can subscribe to the channel. Basically we do live stream and solve LeetCode problems where we discuss the approach of solving the solution. Like we go through every approach and we try to solve the question instead of just blindly solving it. Okay, so let's try to debug the solution. So we have words. Okay, we have prefix. Okay, prefix of 0 is on the left part, we have 0, on the right part we have the prefix of this words 0 and words 1. Okay, and we have the prefix of words of n minus 1 and words of n minus 2 on the left side, and on the right side it is 0. Okay, now we go for every element, and what we do is we calculate the right part, and the right part would be calculated if it is not the last element. Yes, it is not the last element, then we can calculate the right part with the words of I plus 1 and words of I. Okay, and then we have this prefix of I would be, okay, the prefix of I would be the maximum. Okay, here the prefix would be the maximum of prefix of I dot L, okay, the left part, or the prefix of I minus 1 and I. This is also correct. And on the right side, this is the left side, and on the right side we just take the prefix with the right part. Okay, this in turn correct. Okay, this also looks good to me. If it is greater than 0, then we get the prefix of this, and else it is 0. So we have the suffix as the left part and the maximum of suffix of I plus 1 dot R. Okay, and prefix of words of I plus 1 and I. Okay, this also looks correct. Then we have the answer. Okay, it will be adjacent of, okay, if I is greater than 0 and I is less than minus 1, then we calculate the adjacent, which is I minus 1 and I plus 1. Okay, else it is 0, and we have the right part as suffix of this. Okay, we calculate adjacent, we take the right part as suffix of this and R, and the left part is prefix of this current, and we want left here. Okay, or 0, and yeah, then we have our answer. Let's check this. Okay, so let's try to submit this, and hopefully it should submit. Yeah, so we code this solution. We looked at the problems only once, like this was the first time we solved this problem. Then we dig in the solution, like we actually tried the approach. We were having two approach, one is with the segment tree and the other one was, I think, with try. Okay, and this is the third approach, which is slightly simpler compared to other two approaches, and we successfully submitted it. So yeah, this was some random problem solving. Is there anyone following till this? Okay, is there anyone following?